From the job site to the code book, this is a Pool Envy podcast, where licensed pool professionals speak up. Code, compliance, craftsmanship. Hosted by Jason Davies. Licensed across Wisconsin, Florida, and Texas. Your deep end starts now.
Even the ASR is bigger in Texas. When the fix is conflicted. Welcome back, y'all, to the Pool Envy podcast. Today we're discussing a topic that is showing up more and more online and throughout the pool industry. ASR, Alkali-Silica reaction. More importantly, we're going to look at what happens when both the diagnosis and the proposed solution come from the same financial interest. When the fix is conflicted, homeowners should pause and understand the difference between observation, testing, evidence, and commerce.
Let's dive in.
Now, before we begin, let's address one thing immediately. The term concrete cancer. It's emotionally charged. It attracts attention. Emotionally loaded terminology can distract from serious material science and standards-based discussions. Everything's bigger in Texas should not turn into the motto for ASR. This is not a slogan. ASR is a concrete durability issue involving chemistry, materials, moisture, and internal expansion mechanisms occurring inside the concrete itself. Today, we're going to explain in plain English without turning it into a chemistry lecture. There's a lot to cover today, and these terms can get overwhelming quickly. Let's start by explaining what this buzzword is actually about. People hear reactive aggregate, silica, alkalis, expansion, petrography, core testing. Suddenly, it starts sounding like some mysterious, laboratory-only discussion that nobody outside the concrete industry could possibly understand. The reality is, these concepts are not impossible to understand. However, homeowners should understand them, especially before making expensive decisions involving major reconstruction or demolition proposals. First, what is concrete? Surprisingly, many people think concrete is simply cement. It is not. Concrete generally consists of cementitious material, water, sand, and aggregate, such as stone or gravel. Additional materials may be incorporated into the mix depending on the desired performance characteristics, including admixtures or supplementary cementitious materials, often called SCMs, such as fly ash or slag. This matters because ASR is often a hidden problem, not simply a surface issue that you can see. It involves materials already present inside the concrete matrix itself from the day the shell was placed. In other words, this discussion starts long before a homeowner ever notices a crack. Now let's define ASR. ASR stands for Alkali-Silica reaction.
Today's code breakdown.
Alkali refers to certain chemical compounds associated with the cementitious system within the concrete mix. Silica refers to silicon dioxide, a naturally occurring compound found in certain materials that may exist within some aggregates used in the mix. Reaction refers to the chemical interaction that can occur when the materials combine in the presence of moisture over time. Now, let's also define aggregate because that's another term people hear but may not fully understand. Aggregate refers to sand, gravel, crushed stone, or other granular material incorporated into the concrete mix. Some aggregates may contain reactive forms of silica capable of participating in ASR under susceptible conditions. Not all aggregates are reactive. Not all concrete develops ASR. Not all cracking is ASR. That distinction matters tremendously. One of the biggest problems I observe online right now is that people see cracking and immediately jump to a conclusion. Concrete deterioration analysis simply does not work that way. Let's discuss how the failure mechanism works. One of the critical components of ASR is the formation of expansive gel products within the concrete matrix itself. An easy way to visualize this is to think about a dry sponge. When the sponge absorbs moisture, it slowly expands as it becomes saturated. Let's imagine expansion occurring inside hardened concrete, where there is very little room for movement. As the expansive gel products absorb moisture, internal stresses begin developing inside the shell itself. Another way to think about it is like wearing a belt that fits perfectly. And then your waistline gradually expands while the belt stays tight. At first, everything appears fine. Eventually, that pressure builds to a point where something gives. The seam, the button, or the material itself. Concrete is very strong under compression, but it is not indefinitely resistant to internal expansive tensile stress developing from within. Over time, the concrete can literally begin forcing itself apart internally. Now, this is where we need to make another very important distinction. Pool water chemistry is not the initial catalyst for ASR. Moisture absolutely matters. The root issue is still the material system inside the concrete itself: reactive aggregate, alkalis, and sufficient internal moisture conditions. Pool water does not create reactive aggregate. Pool water does not create the original susceptibility within the concrete matrix. However, once susceptible concrete begins deteriorating, moisture exposure can absolutely accelerate expansion and visible distress over time. This is important because pools exist in a very aggressive moisture environment. Not just water sitting on one side of the shell. Pools are constantly interacting with moisture from multiple directions. You may have pool water migrating outward through cracking pathways, groundwater or hydrostatic moisture pressure pushing inward, rainwater infiltration, soil saturation, deck runoff, irrigation exposure, or plumbing-related moisture intrusion. In other words, the shell can become exposed to moisture in a three-dimensional environment once deterioration pathways begin to open. A simple way to think about it is like a cookie beginning to crumble. The weakness may already exist internally. Once cracking and separation begin occurring, moisture now has additional pathways to penetrate deeper into the structure. After that occurs, expansion, deterioration, and secondary damage mechanisms can accelerate. Additionally, if deterioration progresses far enough to expose reinforcing steel, that creates another concern entirely. Once rebar becomes exposed to water and oxygen, corrosion can develop. As reinforcing steel corrodes, it expands. The expansion can create additional cracking, delamination, and further pathways for moisture intrusion into the shell. Routine pool chemistry did not create ASR. Internet discussions often oversimplify the underlying mechanism. The point is that once an internal material science problem exists, continued moisture exposure from multiple environmental sources can help drive ongoing deterioration. That distinction matters tremendously. Understanding the mechanism of failure is what determines whether the proposed repair is actually solving the problem or simply covering visible symptoms. This is also why homeowners need to understand that not all cracking is ASR. Concrete can crack for many reasons: shrinkage, settlement, structural movement, workmanship defects, improper curing, moisture intrusion, corrosion-related distress, sulfate attack, thermal stress. Some cracking may be cosmetic. Some may involve durability concerns. Some may be structural. Many unrelated mechanisms can create physical symptoms that appear visually similar. This is why we wanted to briefly discuss another concrete deterioration issue that has affected parts of Massachusetts and Connecticut, involving pyrrhotite-related foundation deterioration. Different mechanism, different chemistry, different mineral problem. Similar lesson: you cannot simply look at concrete and assume the mechanism. Mechanism identification matters, which brings us to something that has become extremely common online: photodiagnosis. Use caution with online diagnosis. ASR cannot be conclusively diagnosed from a photograph alone. A photograph may raise questions. It may suggest possible durability-related distress. Appearance alone is not confirmation. This is where people get themselves into trouble online. Somebody uploads 3 photographs. 10 people immediately declare, that's ASR. Concrete deterioration analysis is not supposed to work like a social media comment section. A surface crack is an observation. A laboratory report is evidence. Those are two very different things. This is where the conversation needs to shift into controlled testing and standardized analysis.
Today's code breakdown.
Legitimate ASR investigations may involve concrete core sampling, petrographic examination under ASTM C856, sampling procedures consistent with ASTM C823, SEM/EDS, or other laboratory analysis where appropriate, chemical analysis, microscopy, aggregate evaluation, and review of the original concrete mix design and supplier documentation. In some situations, laboratories may also reference standards such as ASTM C1260 or ASTM C1293 when evaluating aggregate reactivity characteristics. Now, let's pause right there and discuss the core sampling process itself, because even the testing process has to be controlled. This is not simply somebody showing up with a random masonry bit and drilling holes into a pool shell. Representative core extraction should be performed using proper coring equipment and controlled procedures designed to preserve the integrity of the specimen for laboratory evaluation. The laboratory is relying on that sample to evaluate aggregate characteristics, internal cracking, reaction products, cementitious composition, and overall concrete behavior. If the sample is poorly extracted, fractured during removal, contaminated, or not representative of the actual condition, the reliability of the conclusions can become questionable. The testing process itself must be credible before the conclusion can be credible. Then we reach another important point. If the same entity identifies the alleged defect, controls the sampling process, interprets the testing, defines the severity, and then sells the reconstruction solution, homeowners should understand there may be a conflict structure involved. That does not automatically mean the diagnosis is wrong. What that tells us is that the homeowner should understand the difference between evidence, analysis, and commerce. A core sample is evidence. A laboratory report is analysis. A construction proposal is commerce. Those are not automatically the same thing. Homeowners need to understand something uncomfortable. The person diagnosing the problem is not automatically independent. In some situations, the larger the alleged problems become, the larger the proposed reconstruction project becomes as well. Again, that does not automatically mean somebody is wrong. Financially interested opinions should never be treated the same as an independent analysis without scrutiny. This becomes especially important when costly repair options are being proposed as liners, fiberglass systems, overlays, major reconstruction, or demolition. If the underlying concrete substrate itself is actively deteriorating internally, homeowners need to ask difficult questions about whether the proposed solution is actually addressing the mechanism of failure or simply covering visible symptoms. Now, let's shift upstream for a moment. Concrete durability begins before the cracks appear. It begins at the plant. One of the most overlooked parts of concrete durability discussions is that much of the information may already exist before the pool is ever built. Concrete suppliers and batch plants commonly maintain documentation regarding mix designs, aggregate sourcing, compressive strength testing, SCMs, fly ash inclusion, and other durability considerations associated with the concrete being supplied. Builders need to understand this. Get the documentation before you accept the concrete delivery. Understand the material being placed into the shell. Once the concrete is in the shell, you cannot separate it back into aggregate, cement, sand, and water later. Nobody is rewinding the hydration process. Nobody is undoing the chemistry. Those materials become part of the structure itself. Years later, when deterioration allegations start showing up, everybody suddenly wants answers about materials that may have been delivered a decade earlier. This is why we also request ASR-related documentation and available material reports from the concrete supplier before accepting concrete deliveries on projects. Durability discussions should begin before placement, not years later after distress allegations begin appearing online. Now, should every builder become a concrete chemist? Of course not. Competent contractors should understand the mix, the aggregate source, the durability strategy, and whether appropriate mitigation strategies were considered. Yes, this is also where regulatory environments matter. For example, in Texas, statewide regulatory oversight is generally more established on the electrical and plumbing side of pool construction, while the broader building oversight, permitting structures, inspection practices, and construction review process may still vary depending on the county or local jurisdiction involved. That does not automatically mean construction is poor. What it does mean is that homeowners should not assume every project is under identical oversight standards or technical review environments. That matters because concrete shells are not inexpensive structures. However, homeowners are making very large financial decisions based on systems they often cannot fully inspect once the shell is complete and covered, which again brings us back to documentation. Good builders should welcome testing, documentation, material transparency, and controlled quality assurance practices. Homeowners are often making enormous financial decisions based on structures they cannot see inside once the shell is complete. When serious deterioration allegations eventually arise years later, those original reports, batch tickets, supplier records, and testing documentation may become some of the most important evidence connected to the project. Lastly, use caution online. ASR is a concrete material science and chemical durability discussion. It cannot be conclusively diagnosed from appearance alone. Many unrelated conditions may create symptoms that look visually similar. The more expensive the proposed repairs become, the more important independent evidence becomes. Homeowners should not fear testing. They should fear making major financial decisions without understanding what is being tested, who controls the testing, whether the testing process is credible, and whether the proposed solution actually addresses the mechanism of failure. Concrete durability is a materials science discussion, not a slogan, not a panic campaign, and definitely not a sales shortcut.
This podcast is for educational and informational purposes only. It is not legal advice, and it is not site-specific engineering, code, or safety determination. All field conditions should be evaluated in context. Thanks for listening to the Pool Envy Podcast, where licensed pool professionals speak up. Hosted by Jason Davies, licensed across Wisconsin, Florida, and Texas. For more insights, subscribe and join us next time.